I asked you to draw the process flow diagram. So I already showed here, this is your activated sludge tank, this is your sedimentation tank, or if you want you can call thickener or settling tank. So let's draw something goes inside. We have to give the notations first. It's already given in the problem. One is F0 and something comes out in the effluent. Let's label the flow rate in the effluent as Fe, and the flow rate of waste sludge as Fw, and the flow rate of your recycle stream as Fr, which I already gave here. And then we can calculate for, now we can give notations for your substrate. So substrate in the feed stream, let's give S0, and microorganism concentration in the feed stream, let's give X0. And then your substrate concentration in the effluent, let we give Se, and your microbial concentration in the effluent, let's give the notation Xe. And then for the waste sludge, the substrate concentration in the waste sludge, we give Sw. And then for the microbial concentration we can give Xw, and for recycle stream we can give the notation Sr, and for microbial concentration in the recycle stream, let's give Xr. So now we can do the flow balance. So what's the, so I already said the input is equal to output because mass is always conserved. So if we go back to the problem, I gave few things. We know the flow rate which goes inside, and we know the waste sludge. Waste sludge, recycle and waste sludge flows are X percentage and 2% of the F0. So we know the flow rate of the waste sludge, which is 2% of the F0. So F0 is how much? 6 into 10 to the power of 6 liters per day. So F0 is 6 into 10 to the power of 6 liters per day, and Fw is 2% of that value, 6 into 10 to the power of 6 liters per day. So this should be equal to 12 and then 4 zeros liters per day. So that's the Fw, that's the flow rate of your waste sludge. And as I said to you, input is equal to output. Yeah? Whatever the mass that goes in, and that should be equal to mass that goes out. So in this case, recycle stream is not a input stream, yeah, because your input stream starts from here. So your feed flow rate is 6 into 10 to the power of 6 liters per day. So which mean input is equal to output. So which mean F0. So number of streams that goes into the system, and then number of stream that comes out of the system. Only these two things matters. So Fe, which is one of your output, plus Fw, that's your another output. So we know F0 is 6 into 10 to the power of 6, that's equal to Fe, we don't know, but Fw we all just now we calculated. So 12,000, sorry 120,000. So therefore Fe will be equal to 6 into 10 to the power of 6 minus 120,000. So this will be equal to some number. So 6 into minus 2. So this will be equal to 588 into 10 to the power of 4 liters per day. So that's your Fe value. So we calculated one unknown parameter. So which means we already performed the total flow balance. So this is your total flow balance. And let's read the problem again. So flow concentration, organic concentration in the effluent and the waste sludge is 20 milligrams per liter. So we have that value here. So SE is equal to 20 milligrams per liter and SW is equal to 20 milligrams per liter. So if SW is 20 milligrams per liter, it should come from here. Yeah? So from the same point, you just split them into two streams. So if SW is 20 milligrams per liter, SR should be equal to 20 grams per liter. So that we calculated already. So which means I ask you to calculate the mass of substrate in the effluent and also in the recycle stream. So the effluent is 20 milligrams per liter and in the SW is 20 milligrams per liter, which mean automatically your recycle stream should contain 20 grams per liter. And if you don't know anything, at least if you know the general idea about microbial reaction or the activated sludge tank, you can easily calculate these values. As I said to you, the microbial reaction happens only in the activated sludge tank. So once it comes out, nothing happens after that. So if your effluent concentration is 20, substrate concentration in the effluent is 20 milligrams per liter, so that will be your value of your substrate concentration in the waste, and that will be the value of the substrate concentration in the FR automatically. So that's the rule. Yeah. So if you know the concentration in the effluent, your substrate concentration, you should know the substrate concentration of your waste, substrate concentration in the waste sludge stream, and also substrate concentration in the recycle stream. By default, they all are same values. Yeah. So what we calculated Fe, and we know Se is 20 milligrams per liter, Sw is 20 milligrams per liter, and we know Sr is equal to 20 milligrams per liter. And then I ask you to calculate, right, the general mass balance. So general mass balance for this system is a bit tricky for the activated sludge unit. Yeah. So because something is getting consumed and something is getting generated, so we are going to write that. So once we perform the mass balance for substrate or microorganisms, you will understand what I mean. So we already performed the total balance, which is F0 is equal to Fe plus Fw. So now we can perform individual or component balance. So let's perform mass balance for each component. So let's begin with the substrate. So how many kilograms of substrate goes inside and how many kilograms of substrate comes out. So that's what we are going to do. So as I said, it will be input will be equal to output. So let's calculate that one. So you have F0, that's your flow rate, multiplied by how many kilograms, or what's the concentration of your microorganisms or your substrate. So now we are performing the mass balance for substrate. So F0 into the concentration of your substrate, which is 300 milligrams per liter, I think. 300 milligrams per liter. So that's equal to Fe multiplied by your Se. So what is your Se plus Fw multiplied by your Sw. So what is this? Is like this is your input. So this is your one output, this is another output. So what we are doing is like input should be equal to your output. hope everything is fine. Liters. Yes. So what is this? But you at the moment you are performing some biological reaction. So which mean it's not something goes in and something comes out. So something is also generated, and something is also getting consumed. Yeah. So what you are generated will you add them with your input, and something will be consumed. So this will make your mass balance correct. So something goes in plus something which is generated, that should be exactly equal to something that comes out plus something which is consumed into the during the course of your reaction or during the course of the process. So this is your overall mass balance expression. So this is such a okay, this is a normal common sense. So something goes in and something is generated. So the total mass whatever you see here, that should be equal to output plus if something is getting consumed. So this should cancel out each other, so which means your mass will be consumed, so it's like it will be conserved. So whatever is consumed here, that will be generated here. So in that way you will have a perfect balance in the mass. So if the total is 100 kg, so this value will be equal to 100 kg. So this is your overall mass balance equation. So this is a bit tricky, but you can learn mass balance only by practicing and trying to solve few more problems by yourself. Yeah, but if not you, I know I know you are already in the week 10th and probably you might not have time. So at least try to solve this problem. Whatever I'm solving now, just close the notebook and take the question and try to solve it yourself. So if not, it will be very difficult during the exam day. So this is your overall mass balance equation. So what we are going to do is we are going to substitute these values. So we are going to perform the substrate mass balance. So how much mass of substrate goes into the system and how much mass of substrate comes out of the system. So you have one input and you have two outputs, and then you have something that might be generated and something is getting consumed. So something is getting consumed, that's why you produce more microorganisms. Yeah. So and whatever the component which is consumed, that will be your organic compound, or if you want we can call it as a substrate. That's what we call when we are studying microbial kinetics. So let's substitute this value. We know what is F0, which is 6 into 10 to the power of 6 multiplied by 300. So the unit will be like so F0 is expressed in terms of liters per day multiplied by milligrams per liter. So it will be like milligrams per day plus what is generated. So this is, we are performing mass balance for substrate. Obviously substrate you cannot generate them because this is the quantity which is getting consumed. So generated will be equal to 0 plus your Fe value. What is your Fe value? We already calculated, I think. Fe value is 588. If you go back here, we calculated this value Fe. So I just substitute here 588 into 10 to the power of 4 liters per day multiplied by what is the concentration of substrate in the effluent. I think it's 20 milligrams per liter, I think. Yes, 20 milligrams per liter. Let us get cancelled plus we know Fw, this value I already gave in the problem. So 120,000 multiplied by liters per day multiplied by your substrate concentration is again 20 milligrams per liter plus something is consumed. Your substrate is obviously getting consumed. So if we have to solve this problem, yeah, so how much is getting consumed? So we have all the other values, all we need is to calculate what's the quantity of substrate consumed. Yeah, so if you multiply all this value, you will get something like 1.8 into 10 to the power of 9 plus 0 equal to 1.18. Just to check the calculation yourself, I might have done some mistake, but you have to calculate. I already showed you how to do this. Plus consumed, therefore consumed or substrate consumed you should have a lot of patience to solve all this problem will be equal to 1.68 into 10 to the power of 9 milligrams per day. So pay attention to the units. So your flow rate is expressed in terms of liters per day and your concentration is expressed in terms of milligrams per liter. So liter and liter get cancelled, so you will end up with milligrams per day. So you are consuming 1.68 into 10 to the power of 9 milligrams per day. So during the reaction, and then I gave you the yield value, I think. Okay, in the exam, if I didn't give the yield value, just assume yield is 50%. So yield is equal to substrate microorganisms generated by substrate consumed. Or microorganism generated will be equal to yield multiplied by substrate consumed. So this one I already taught you in the microbial kinetics chapter. So you need to have some understanding from the microbial kinetics to solve this activated sludge tank problem. So that's why I covered microbial kinetics and then I came to this tutorial session. If you remember, I posted tutorial 1 and then I didn't post after that. I wanted to finish microbial kinetics and then I can come to this type of problems. So now you know what is an yield, you know what is why substrate is getting consumed, you know why microorganisms are getting generated, because those things you already learned from microbial kinetics. So now you know the yield value, so from that you can calculate microorganism generated. Yield is 0.5. So 0.5 means like you generate 0.5 grams of microorganisms if you consume 1 gram of your substrate, or if you want to say it the other way around, for every 1 gram of your substrate consumed, you produce 0.5 grams of microorganisms in the reactor. So 0.5 multiplied by your substrate consumed, you already calculated. So just now 1.68 into 10 to the power of 9 milligrams per day. Always write units, and yield don't have an unit. So some microorganism generated, that will be equal to 8.4 into 10 to the power of 8 milligrams per day. Check the numbers yourself. So I used the Excel sheet. So I asked this question in the last year to the students. So that's why I thought to give you, to show you one of the exam problems. So you will get some idea what type of, so what is a mass balance and and how to perform it. You might expect this type of questions in the final exam. So practice it. If you don't practice it, if you practice this problem one time in home, you will do that in less than 10 minutes for this problem. I'm going here very slow. I can solve this in less than 5 minutes, but I'm just explaining very slowly so that if I go fast you won't get anything. So just explaining it bit by bit. And now we can perform. You have only two components, we already did the component balance for substrate. We already calculate how much substrate is consumed from that, and now we know how many how many grams of microorganisms you generate in the activated sludge unit. So now we can perform your microorganism balance, or this second component balance. So mass balance for component 2, or compound 2 if you want. So this is nothing but your microorganism. So microorganism in, that should be equal to microorganism out. So do the same thing, F0 multiplied by X0 plus, as I said, something is generated, that should be equal to FEXE plus FWXW. This is your output stream 1 and this is your output stream 2 plus consumption. So one thing is, from the, you already have the knowledge of how the microbial reaction works. So during a microbial reaction, only your substrate is getting consumed, not your microbial concentration. So consumption factor will be 0 when you perform a mass balance for microorganism, because you are going to generate something. So this value has, this quantity has some number, while consumption will be 0. So F0, let's put the number for F0 we already, and oh sorry, I forgot to mention X0, this is 0 milligrams per liter, so which means the whole quantity will become 0 plus, we know how much microorganisms we generated, so 8.4 into 10 to the power of 8 milligrams per day. We calculated this is calculated value, that will be equal to, we know the flow rate of Fe 588 into 10 to the power of 4, Xe we don't know. We don't know what's the concentration of microorganisms in the effluent. In fact, I ask you to calculate that value, plus 120,000. This is your flow rate of your waste sludge multiplied by, we know the concentration of microorganism in the waste sludge. I already gave you. If you go back to the problem, I gave you here. Concentration in the waste sludge XW is 500 milligrams per liter, this value. So X multiplied by XW is 5000. So if you solve this, you will get Xe will be equal to somewhere around 6 into 10 to the power of, no, Xe will be somewhere around 40.8 milligrams per liter. Yes. So that will be the concentration of your microbial concentration in the effluent. I think we answered all the questions. Yeah? We calculated the 5 mass of substrate, microorganism in the effluent, and the recycle stream. So okay, so if Xe is equal to 40.8, XR should be equal to 40.8 as well, because if we go back to the problem, if you see this tank, let me change the color. So something you take from this point, it comes out, and then you split into 2. So which means the concentration at this point and this stream should be same. So if XW is equal to 40.8 milligrams per liter, XR should be equal to 40.8 milligrams per liter. So I think now we solved almost everything in the problem. So I think this is more than enough. So you might expect some problems similar to this in the final exam. So try to, you must practice it. If not, you will lose the track and you won't even understand how to do the calculation. So try to practice. Yeah? So I will upload this one today tonight. So it's already midnight, I think. And then try to solve this, and then please practice. Yeah, I really beg you to practice. If you don't practice, it will be very difficult in the final exam. So don't take it lightly, you must practice it. If not, it's going to take, you cannot solve this in time. Yeah, so try to practice it. Yeah, thanks for listening.